Okay, I'm going to take you through the exercise now. Level 1. So first of all, you can use the substitution method, which is what I have done in my notes, or you can use the brackets. Derivative must be in front. Because I popped the 2 in there, balance it outside. Now add 1 to the power, derivative disappears, and tidy up. So 2x, add 3 to the 4 over 8, add c. Get you that a little bit quicker. Number 2. So minus 1, 1. 3 minus 2x to the 4th, bracket. The derivative is minus 2, so I must have a minus 2 there. Balance it outside by minus a half. When you integrate, derivative disappears. You add 1 to the bracket, divide by it. This one's got limits in. So I would write that as minus a tenth. And then it's 3 minus 2x. So I put in 2 times 1 is just 2 to the 5. Minus. And then put in minus 1. So 2 times minus 1 is plus 2 to the 5. So it's minus a tenth, 1 to the 5, minus 5 to the 5. And just putting that through your calculator. And times it through should give you the 312.4. Question 3, not 2. 1 add 4x root. I see a bracket there. So that is 1 add 4x to the half. To integrate a bracket, the derivative must be in front. The derivative of that is a 4. Pop your 4 in, balance it outside with a quarter. Now add 1 to the power. Divide by the new power. There were limits here, 2 and 0. So I would bring that out, so that's 2/3 times a quarter, so it's 2 over 12, and then sub in your 2, so it's 8 to the 3 over 2, sub in your 0, and just put it through the calculator. And question 4, part 1. Hopefully these aren't overly bad. I say hesitantly because I know it's hard. Okay. It's an x function in the bottom, so I'm thinking logs. Do I have the derivative on top? What's the derivative of x? 1. So it is on top. I don't have to balance this one. Doesn't happen often. So you log the bottom line. 2, 1. Sub in your 2, sub in your 1. Remember log 1 is 0. So that just gives you that answer. Okay, now let's see what we've got coming up now in the next couple. Part 2. Minus 3, minus 1. Oh, that's just the same. So it is derivative. The bottom is on top. So you log the bottom. Oh, I see what's different about this one. It's the minuses. So log modulus of minus 1. Take away. Remember the modulus just means find the positive. And that is not. So there you go. Number 5, part 1. An e function. Okay. Now, remember when you differentiate an e function, you must have the derivative in front. So I must have the derivative in here. Because I popped that 3 in, balance outside with a 3rd. Now you're ready to integrate. Now do you remember how you differentiate an e? You had the derivative, then it went to the function. So if you're going backwards, it just goes back to the function and the derivative disappears. And then just put in your 2, e to the 6 minus e to the 0. So it's a 3rd e to the 6 minus, that's 1, minus a 3rd. Number 2 and number 5. Not pi over 4 cos 2x dx. Now where does cos come from? Remember sine goes to cos, but you must have the derivative in front. The derivative is a 2. Balance outside, because I just popped the 2 in, you must balance outside. When you integrate, the derivative disappears, so you go back to sine. So whenever you're putting it through, that half just sits there. So it's sine 2 pi over 4, which is pi over 2. Take away sine 0. So that is a half times 1, which is just a half. Okay. Hope we're doing okay here. Question 6. Not pi over 4, 3 cos x minus sine x dx. Now quite often I've got a complicated one like this, I split it up. So 3 can just go through the integral sign, leaving me cos x. The minus can go through the integral sign, leaving me sine x. That's quite handy doing it that way. Right, let's think of this. Where does cos come from? Sine goes to cos, derivative in front. The derivative of x is a 1, that's in front. That is good to go back to sine. Right, where does sine come from? Remember, cos goes to minus sine. And the derivative is a 1, so that's there, but I don't have my minus. So pop it in, balance it outside. Outside now becomes plus. This goes back to cos x. And then you just put in pi over 4 and 0 and just run through with that. Number 7 is x squared. Now number 7, I know by looking at it, if we even write it out, that it's an awkward one. It's a bracket. Now, what do we need for a bracket? We need the derivative in front. If you can't do that in your head, go over to the side. See my fingers here? That's the bit I need the derivative of. That differentiate is 3x squared. I nearly have it. So what I have to do is pop a 3 in there and balance it outside. I now have the derivative in front. I can integrate. So you add 1 to the power and divide by it. And don't forget your c. So that is x3 plus 2 to the 4 over 12 add c. I'm just looking at my notes there. I have done it through substitution. But I very rarely use substitution unless I have to. And I think we might see when I have to do it in some of these exercises, but we'll just hold tight. So what do I see there? I see a bracket. So the top line, just let that sit. That is x plus x squared to the minus a half. Right, how do you integrate a bracket? You must have the derivative in front. Now, what's the derivative of this? 1 plus 2x. That differentiates to that. I've got it in front. Brilliant. No balancing, nothing to do. So add 1 to your bracket. So add 1 to that's a half. Divide by it. And don't forget your c. Divide by a fraction is turn it upside down. And you'll see that is much, much, much quicker than using substitution.